Yes sir, ये दिख रहा है ना? Yes sir.
Yes, carry on.
Okay. So if hydrogen, if we consider the configuration of hydrogen, that is 1s1. So here hydrogen has one valence electron. So it can share their electron, this valence electron, with another hydrogen atom that is from same orbital, 1s orbital, and it will form the hydrogen. This hydrogen and this hydrogen will share their valence electron, and it will form a covalent bond where the two electrons are shared by the two atoms. Okay, sir. Okay. So whether if we consider the formation of NaCl, here sodium has configuration 1s2, 2s2, 2p6, 3s1, and chlorine has configuration. See, so here in this, to form the NaCl molecule, NaCl compound, here sodium will release their electron. Sodium will release their electron, and it will form sodium positive ion. And chlorine will gain that electron, and it will form Cl minus ion. And after that, sodium positive and Cl minus will form NaCl compound. Yes, sir. And let us consider the formation of ammonium positive ion. Ammonium positive ion, here in ammonia, there is one lone pair of electron. In ammonia there is one lone pair of electron, and in H positive there is no electron in H positive. In H positive there is no electron. So from ammonia, nitrogen will donate the whole lone pair, that is two lone pair electron, to form a bond to H positive, and it will form NH4 positive ion. NH4 positive ion. Yes, sir. And this here hydrogen molecule is formed by covalent bond, NaCl molecule is formed by ionic bond, and NH4 positive molecule is formed by coordinate covalent bond. Yes, sir.
What is octet rule? What the main application of octet rule?
Octet rule means one atom always want to get the noble gas configuration. Any atom in the periodic table, want to get stabilized, they have to get the noble gas configuration, and this rule is called basically octet rule. Whether if we consider the hydrogen, basically the octet rule is, okay, again I am telling, to get the noble gas configuration, or in valence shell they have to get the 8 electron. So this rule is called octet rule. If we consider sodium atom, here the sodium has valence electron of 1. If it lose that electron, and it will gain the configuration of neon. ठीक है, जैसे ऐसे ही fluorine has configuration 1s2, 2s2, 2p5. If fluorine get 1 electron, then it will get the configuration of neon. Similarly, oxygen want to get 2 electron to get the configuration of neon. That means every atom has a tendency to get stabilized, and it can stabilize by gaining electron or losing electron to get the valence. To getting 8 electron in their valence shell. So this rule is basically called octet rule. तो मतलब याद है, लेकिन सेंटेंस बना नहीं पा रहा इसमें.
No problem.
Yes, sir.
What is the limitation of octet rule?
Limitation of octet rule. If we see the molecule of beryllium chloride here, 1 minute. Basically, in octet rule, molecule has to get the 8 electron in their valence shell. It can happen by sharing of electron or by losing of electron. If we say beryllium chloride molecule, here beryllium has 2 electron in their valence shell, and chlorine has 7 electron in their valence shell. So here chlorine getting the 8 electron in their valence shell, but beryllium atom is getting only 4 electron in their valence shell. Here octet rule is not following. That means this molecule is electron deficient. Electron deficient molecule. The beryllium atom is electron deficient. It has to get the 8 electron, but by sharing the 2 electron, it getting only 4 electron. Similarly, in BF3, boron trifluoride molecule, the boron atom get only the central boron atom has only 6 electron in their valence shell. 6 electron in their valence shell. Similarly, BH3 boron atom has 6 electron in their valence shell. Similarly, these molecule are called electron deficient molecule. Similarly, if we consider SF6 or PF5 molecule, PF5 or SF6, here sulfur will get 12 electron in their valence shell, and phosphorus will get 10 electron in their valence shell. Phosphorus and sulfur will get 10 and 12 electron respectively. So basically, octet rule was that every atom has to get 8 electron in their valence shell. But here we can see beryllium, boron get only 8 or 2 or 6 electron, but here sulfur, phosphorus getting excess electron. So this rule is limited to not only but these all molecules are stable. So octet rule is not following. Say yes sir.
Yes.
So octet rule, yes sir. यही this description हो जाएगा सर. Yes.
What the difference between molecular orbital and atomic orbital? What the difference is?
Yes sir. Molecular atomic orbital is just for one atom. If we see 1 minute, thus we can see the hydrogen molecule. Here hydrogen has 1s orbital. 1s. This orbital is called atomic orbital. This orbital is in shape of spherical shape. If these 2 hydrogen atoms are combined, if 2 atomic orbital of hydrogen, 1s and 1s combined, this can be by it can form then their positive and positive, or it can provide it can add by positive and negative wave function. So if positive and positive overlap, then it will make a constructive wave, that is it will become larger or constructive. Whether if it formed by positive, combined by positive and negative wave function, then positive and negative like that, positive and negative. So here this orbital, that means we can say only that atomic orbital is just for one atom, and molecular orbital is for overlapping of 2 orbital. That can be overlapping of 2 wave function orbital, 2 wave function of atomic orbital. Wave function of atomic orbital, that is it can form constructive wave function or destructive wave function. From constructive wave function we can get bonding molecular orbital, and from destructive wave function we can get anti-bonding molecular orbital. Bonding molecular orbital has lower energy than anti-bonding molecular orbital. Yes sir. ठीक है सर. और थोड़ा बोलना.
Yes, good. First of all, note down in a topic of upside chemical bonding topic name. Yes ना. बोर्ड पे टॉपिक का नाम लिख दीजिए आप.
ओके सर, ठीक है.
केमिकल बॉन्डिंग.
यस सर.
What the difference between lattice energy and lattice enthalpy in chemical bonding? Any example of these one?
No, sir. I don't have idea. Lattice energy and lattice enthalpy. I don't know. Sir. That question I don't know, sir. Can you?
Yes, what the difference between bond length, bond angle, bond enthalpy? Explain with example.
Bond length.
Bond angle, bond length, bond strength, bond enthalpy, bond energy.
Yes. So basically, bond length. Bond length is defined as the distance between two atoms which form the bond. If we consider the molecule is AB, then A has one center, that is this, and B has one center. This center of A2, I have to, I think, remember this, memorize this distance. From one center to another center, this distance is called bond length. ठीक है? तो यहाँ पे मतलब क्या है? If we consider the bond length of HF, HCl bond order, HBr and HI. Here you can say fluorine. Since one atom is same, fluorine is the size of other atom. Size of fluorine is smaller than chlorine, than bromine, than iodine. So the distance from hydrogen to fluorine is lower than the distance from chlorine. Then that means we can say that bond length of HF is lower than bond length of HCl, is lower than HBr than HI. Since iodine is bigger in size, so hydrogen and iodine bond length is more than the hydrogen and fluorine. Okay, so this one. If we consider the bond angle, the minimum angle between two bonds. If we consider this molecule AB2, the minimum angle, the angle between two bonds is called bond angle. Let's see AB2. This it can happen like this or here. So here, this angle and this angle. This angle is approximately 180 degree and this angle is approximately 120 degree. Let us consider for sp hybridization, the bond angle between two bonds. For sp hybridization, the bond angle between two bonds is 180 degree. For sp3 hybridized atom, the sp3 hybridized molecule, sorry, sp2, the bond angle between two bonds is 120 degree. For sp3 hybridized atom, the bond angle between two bonds is 109 degree 28 minutes. Okay. So if we consider, let us take another example. Let us consider another example. Here, I am taking example of H2O and H2S. Here, H2O and H2S. Okay, so in oxygen, since here you can see this angle is called bond angle. If one can ask the bond angle, which bond angle is more? So here, since oxygen is more electronegative, you can see the central atom here, only difference between the central atom. Here central atom is oxygen and here central atom is sulfur. So oxygen is more, electronegativity of oxygen is more than sulfur. So oxygen can attract the hydrogen-oxygen bond, hydrogen-oxygen electron, bonding electron to itself, same. So it can repulsion can happen, and this bond angle will become larger. And this bond angle, since sulfur is less electronegative than oxygen, so bond angle will be less. So we can say that H2O has more bond angle than H2S. Though they have the same hybridization sp3, though they have the same shape, that is V shape. Though they have the same hybridization or same shape, but their angle, bond angle between H2O and H2S are different. More than one degree, they are different from more than 1 degree. Yes, sir. This is bond angle. Sir, explanation थोड़ा और करना पड़ेगा क्या?
Yes, good. Carry on.
Yes, sir. So ये हो गया. तो और क्या पूछा था सर आपने? Bond angle. Yes. Bond energy. So if we consider there are two in between covalent molecule, there are three types of bond can form. One is single bond, and one is double bond, and one is triple bond. Single bond, double bond, and triple bond. If you can see in ethane molecule there is only carbon-carbon single bond. In ethene molecule there is carbon-carbon double bond, and ethyl molecule there is carbon-carbon triple bond. And we know that the bond length of carbon-carbon single bond greater than carbon-carbon double bond greater than carbon-carbon triple bond. As the bond length increase, bond energy will automatically decrease. That means bond length तो मतलब क्या है, ज्यादा bond length increase होगा. Bond length increase होने से bond energy मतलब bond तोड़ने का मतलब bond breaking energy lower हो जाएगा. So इसलिए इथेन का bond energy lower है. तो this ethane has more bond energy than ethene, then carbon-carbon single bond, that was it, ethane. Okay, sir.
Yes.
Yes, sir.
Next is Vesper theory. What the main application of Vesper theory?
From Vesper theory, we can know the exact shape of molecule. If we consider the water molecule, here, hybridization is sp3, but it has only 2 bond pair and 2 lone pair. It has only 2 bond pair. So this molecule can have only this shape. This molecule can have only this shape. So from Vesper theory, we come to know the exact shape of the molecule. If we consider another example, that is PCl3. If we consider another example, that is PCl3. That is a very interesting example. Here the hybridization is sp3d. Here the hybridization is sp3d, and it has only 3 bond pair and 2 lone pair. So in sp3d, the geometry of the molecule is this one. The geometry of the molecule is trigonal bipyramidal. So here we can take this lone pair of electron like that. Here lone pair of electron, we can take this chlorine, and whether we this one. Similarly, we can take this one. So in all the 3 possible structure, there is 3 possible structure of PCl3. In this molecule. We know from Vesper theory, we know that lone pair has maximum repulsion, then lone pair, bone pair, then bone pair. So in this, if the angle between lone pair and lone pair is more, then the repulsion will be more, and if the angle between lone pair and lone pair is less, then the repulsion will be more, and the molecule will be unstable. The structure will be unstable. Here you can see the angle between this lone pair and this lone pair is 90 degree, and here the angle between this lone pair and this lone pair is 180 degree, and here it is 120 degree. So the stability is if we order this the structure stability, then here the lone pair distance and the angle is 180 degree, here 120 degree, and here 90 degree. So in this molecule, the angle is since 180 degree, it should be more stable. So this one, B will be the more stable structure. Then B will be more stable structure. Then this one, this is sorry, this one C, and then A. Yes, sir. So from VSEPR theory, we can know the exact structure of the molecule. From VSEPR theory, exact shape of the molecule. Why? Since VSEPR theory exactly deal with the repulsion, the actual stability of the shape. Okay, sir. So is this correct, sir?
Yes, good.
सर एक्सप्लेनेशन ठीक है ना, मतलब मैं जैसा बोल रहा है कि जो आप क्वेश्चन पूछ रहे हैं तो मैं एग्जांपल के तरीके से ही आंसर देना मतलब अच्छा समझ रहा हूं सर। यही
फर्स्ट ऑफ ऑल एक्सप्लेन देन एग्जांपल।
यस सर।
एनी लिमिटेशन ऑफ एस्पर थ्योरी, डिसएडवांटेज, लिमिटेशन?
डिसएडवांटेज सर याद करना पड़ेगा, याद तो नहीं है अभी सर। डिसएडवांटेज,
यस, लिमिटेशन जो भी टॉपिक है उसका लिमिटेशन होना बहुत जरूरी है, ठीक है ना?
यस सर, मतलब एक से बढ़कर एक है ना टॉपिक, तो लिमिट। सर मैं एक आपको बात पूछना चाहता हूँ, जो मैंने अभी सिर्फ ओपी चंदन का 3 बुक था ना, फिजिकल, इनऑर्गेनिक और ऑर्गेनिक का, वही 3 पढ़ रहा हूँ, मतलब बेसिक के लिए। तो उसके बाद मतलब अच्छा ओपी चंदन भी बहुत अच्छा बुक है ना, तो वहां से मतलब थ्योरी अच्छे से रीड कर रहा हूँ, हो जाएगा ना सर?
यस यस, वहां से सही है। उसके बाद लिमिटेशन आपको बुक में नहीं मिलेंगी, लिमिटेशन में भेज दूंगा। लिमिटेशन के लिए आपको गूगल सर्च करना पड़ेगा, वहां पे मिलेगी, क्योंकि बुक्स में लिमिटेशन नहीं होती है, बुक्स में नहीं होती, ना किसी नोट्स में मिलेंगी।
ओके सर।
नेक्स्ट मूव ऑन बीबीटी। व्हाट द मेन एप्लीकेशन ऑफ बीबीटी इन केमिकल बॉन्डिंग?
फ्रॉम बीबीटी मेन एप्लीकेशन only sir, sorry sir, main application only bonding, I think sigma bonding, pi bonding, no sir, that I don't know sir, that is main application तो क्या था सर इसका?
बैलेंस बॉन्डिंग बताइए आप कुछ आंसर, मैं आपको व्हाट्सएप पे दे दूंगा सारी चीजों के, है ना?
ओके। और सर एक आपको मतलब एक काम कीजिएगा, जो जो क्वेश्चन आप पूछ रहे हैं तो उसका अगर आप लिख लीजिएगा तो मुझे फोटो सेंड कर दीजिएगा तो अच्छा रहेगा सर।
हाँ ठीक है, उनके जितने भी क्वेश्चन जो क्रॉस हो रहे हैं, जो आंसर नहीं, वो व्हाट्सएप पे करते हैं, क्योंकि यहाँ आंसर देंगे तो टाइम नहीं रहता ना हमारे पास, उतना ही टाइम है, तो इसलिए आंसर सारे आपको व्हाट्सएप पे मिलेंगे, ठीक है?
अच्छा सर, ठीक है सर। यस, तो VBT, from VBT, it was given by Hitler and London, fasting Hitler and London around 18 and 1927. Okay, so VBT is basically the valence bond theory where the valence orbital of one atom is combined with valence orbital of another atom. For example, if we consider the formation of hydrogen molecule, here hydrogen has one s1 orbital, the valence orbital is 1s. So this 1s orbital of one hydrogen atom, 1s orbital of one hydrogen atom, and 1s orbital of another hydrogen atom come towards approaches each other, and at some time it overlap with each other, and it will form the hydrogen molecule. It will form the hydrogen molecule. Similarly, for the formation of HCl, molecule, here hydrogen has 1s orbital, 1s1 configuration, and chlorine has 3s2 3p5. Okay, so here if we consider this one 3s and this 3p electron. Okay, so here to get the Nobel-gas configuration, chlorine is only ahead of only one electron, and hydrogen will come and share this electron to chlorine. We can see this as a orbital overlap also. Hydrogen has 1s orbital. This is pz orbital of chlorine atom, and this come and overlap with hydrogen, and it will form. This is the 2pz orbital of chlorine atom. This is the 1s orbital of hydrogen atom. These two orbital overlap, and it will form HCl. Basically, we know we can tell that the valence bond theory is the overlapping of orbital which has unpaired electron. Basically, valence bond theory, overlapping of orbital which has only unpaired electron. We can see that carbon has only 2 unpaired electron in ground state. 2 unpaired electron in ground state, but if it goes to excited state, it will get the 4 unpaired electron. So it can overlap with 4 other hydrogen atom, and it, so the covalency, we can tell also the covalency of carbon is 4. Covalency of carbon is 4. Similarly, sulfur can form 6 bond with fluorine atom, so it can form SF6. The covalency of sulfur is also 6. So basically, maximum covalency of sulfur is 6 or 6. The basically valence bond theory is, again I am telling that the overlapping of valence orbital which has unpaired electron. Yes, sir. Which has unpaired electron. Okay, sir.
Yes. What the difference between base pair theory and VVT?
What is the difference between base pair theory and VVT? From VVT, we don't know the exact shape of the molecule. From base pair theory, we can know the exact shape of the molecule. Exact shape. From base pair, we can know the exact shape. But from VVT, we can know only the bonding between the molecule. But we cannot predict the shape of the molecule. Okay? So from base pair, we can know the exact shape. That is the main difference, I think. Yes.
Next is, what is hybridization? What the main application of hybridization?
Yes, hybridization is the mixing of atomic orbital. Hybridization is basically the mixing of atomic orbital which has same energy. So if we consider the so if you consider in carbon, basically for hybridization, the atomic orbital should have the same energy. If 2 orbital hybridize, then the hybridized orbital should be 2. If 3 orbital hybridize, 3 atomic orbital hybridize, then the hybridized orbital will form. That is, hybridization is basically the mixing of atomic orbital. So if we consider carbon has configuration 1s2, 2s2, 2p2. I have already told that in ground state carbon has 2 unpaired electron. This is in ground state. In excited state, this has the 2s electron will go to 2p, since it has almost same energy. So here all four orbital can overlap with each other, and it will form the hybridization of sp3, and we will get how, since here 4 atomic orbital, 1s and 3p orbital overlap, so we will get 4 sp3 hybridized orbital. 4 sp3 hybridized orbital. All have the same type of shape, same bond angle between them. So sp3 orbital is looking like that only. This one, this one, this one, and this. All have the same type of shape, and angle between them is same angle between all of them is 109 degree, 28 degree. Similarly, in oxygen you can check 1s2, 2s2, 2p4. So 2s electron is this, and 2p electron is this. Here the valence orbital overlap between them, and overlap, all will, sorry, valence orbital is mixed between themselves and it will form sp3 hybridized orbital. Since 4 orbital overlap, 4 orbital hybridized, so we will get 4 sp3 hybridized orbital. Yes, sir. 4 sp3 hybridized orbital. Yes. Similarly, in boron configuration is 1s2, 2s2, 2p1. So 2s has 2 electron and 2p has only 1 electron. 2s electron will go to the excited to 2p electron. Here 3 orbital has 1 unpaired electron. So this s and p2 orbital overlap and it will form sp2 hybridized orbital. Boron will form sp2 hybridized orbital, and since 3 orbital overlap, we will get 3 sp2 hybridized orbital. Okay, so here 3 sp2 hybridized orbital, and the bond angle between them is, the shape is same, the bond angle between them is 120 degree. Yes sir. इतना ही ठीक है सर, और बोलना पड़ेगा. Yes. So from hybridization, we know that from hybridization. So application of hybridization देखना पड़ेगा. Application so मतलब structure geometry. Yes.
SP hybridization, SP2, SP3.
Yes sir. So from hybridization, we know the geometry of the molecule. We know the exact geometry of the molecule. Yes sir. Is it okay sir? Geometry? Yes.
Yes. Formation of hybridization.
But please sir again.
Formation of hybridization.
I am not getting that question sir. What?
Formation of hybridization.
Coordination?
Formation, SP2, SP3.
Yes sir. I have told already. This one this one boron I have explained. In carbon I have sp3. Yes sir. For sp I think I have to go to carbon dioxide. Yes sir. sp hybridization. Yes.
Yes. What the example of hybridization of elements involving d orbital?
Hybridization of example.
Yes.
That is ECl5. Here phosphorus use 3d orbital and we get sp3d. Wait 1 minute, I am explaining. If we check phosphorus has configuration 1s2, 2s2, 2p6, 3s2, 3p, 3. Here 3s has 2 orbital and 3p orbital has 3 orbital. Here 3d orbital is totally vacant. 3d orbital is totally vacant. So the paired electron from 3s, the paired electron from 3s will go to 3d orbital. Paired electron from 3s will go to 3d orbital, and now we are getting 5 unpaired electron. So this is 3d, this is 3p, and this is 3s. So all the unpaired electron orbital will overlap and we will get the hybridization of sp3d. Similarly, in sulfur, we will get the hybridization of sp3d2. Similarly, in sulfur, we will get the hybridization of sp3d2. Yes, sir. Or explain.
Yes. Any limitation of hybridization?
From hybridization, we know the exact geometry, but shape, exact shape we cannot predict. फॉर हाइब्रिडाइजेशन से ही तो ये सब क्या आया था. So exact shape of the molecule. I have to check their limitations. All limitation I have to check again. Yes, sir.
Yes, hybridized atomic orbiter do not accurately predict the observed spectroscopy energies of the species.
Hmm.
Yes,
Yes, sir.
one point.
Yes, sir.
Hybridized atomic orbital do not accurately predict the observed spectroscopy energy.
Yes, I was exact spectroscopy energy. Yes, sir.